Okay, let's kick it off. Well, hello, everyone. Thank you for joining our webinar about performance-oriented UX design that specifically focuses on performance-oriented content loading. And before we jump in, I will share a little bit about product science, and we will also introduce ourselves. So product science offers a new set of tools for mobile app developers that allows them to have instant and deep insight into the behavior and the performance of their applications before they are launched into production. And we will demonstrate the capabilities of the product science tool later on in this session. So who are we? Leading this webinar today are myself and Dr. Anastasia Matviva.
Yeah, hi, would you switch the slide?
Sure.
Hi everybody, my name is Anastasia. My background is in mathematics and research. I've been with product science for a while now, optimizing and analyzing different apps on the same team as Jordan, and she'll tell you a bit more about our joint experience here.
Yes, so if I haven't already mentioned, my name is Jordan Wooten, and my background is also in mathematics. And Anastasia and I have been working with the product science tool for over a year, and we have spent that time analyzing and optimizing the performance of multiple mobile apps from various industries and on different platforms. And we have seen that when it comes to mobile app performance, the most common optimization opportunities are due to the fact that UX design and performance live in parallel worlds. And performance as a topic can be vague and overwhelming, but no one wants to use a slow app. And with that, we will get into the agenda. So this webinar is designed for product managers and UX designers, and also mobile app developers who are eager to improve the performance and user experience of their apps. So our agenda is as follows. We will cover what are UI interactions and why are they important, common inefficiencies with UX design for mobile apps, how to avoid delays when designing, how to spot efficiencies using the PS tool, and success stories that we've had with using the PS tool. And throughout the webinar, we will dive into various examples of suboptimal mobile UI changes and how they relate to performance. We will then review how the product science tool allows and empowers its users to identify any performance delays that may be slowing down their app. So what are UI interactions? Before defining what UI interactions are, we must first define UI. And for the purpose of this webinar, we will define UI as what a user sees and feels when they interact with a mobile app. Keeping this in mind, UI interactions refer to any time a user interacts with the screen of their mobile device to achieve a desired outcome. And to demonstrate this definition of UI interactions, we have this diagram here. And here we have three sections: action, UI change, and reaction. So again, first we have user action, and this could be anything from a tap, a scroll, or a swipe, any action that the user takes to interact with the UI. And then we have the UI change, and the UI change occurs as a result of the user's action. Once a user completes this action, the UI will update to reflect that. And this update could be an animation, such as a loader or a transition animation. It could also be a layout update or even a splash screen where we just see the logo of the app. So all of these things fall under the category of UI changes, and they serve as the intermediate step between a user's action and the resulting reaction. So that brings us to the end of the diagram where we see the reaction, which is usually the final view or the outcome that the user is trying to achieve with their initial action. And we also have wait time included in this diagram. And notice how it spans across the entire flow. This wait time represents the amount of time it takes for a user to view the resulting reaction after they have interacted with an app's UI. And wait time should not be confused with loading time because it measures all of the time that takes place between an action and the resulting reaction, not just the amount of time it takes to load the final view after a UI change occurs. To provide an example of a UI interaction, here we have the Instagram page for two of our founders of product science, David and Danielle Lieberman. And just noting that this example, as well as all of the following examples, have been slowed down by 50%. So you can clearly see the changes that are occurring. And as shown on the video, here we selected a photo from the profile feed. And as a result, we see the dedicated page for this post. The action is to tap the image. The UI change is the animation that occurs to open and show the post. And then the reaction is the final view or the post page. And this interaction is a smooth experience for the user because here there are no delays. The data for the selected photo was likely prefetched, which is why the final view appears almost instantly. However, unlike the previous example, some UI changes occur as a result of a UI interaction, and it's not a very smooth experience. And this is the case if there is additional data that needs to be loaded to show the final view. In this case, it is harder to predict user wait time because it does depend on how and when the data is being loaded. However, in order to communicate to the user that their action was successful, that needs to be indicated on the screen while the data is loading. So this brings us to the question, how do we keep users engaged and show them that progress is being made without creating an extra wait time? So now that we know the flow of action, UI change, and reaction, I will share a few quick examples of bumpy UI changes to highlight the problems with keeping UX design and performance separate. So here we have an example of a loader from a popular scheduling app. And as shown in the video, the user taps to select an event, then we see a transition animation and loader, and lastly, the UI updates and we see the event details. And I previously mentioned the question of how do we keep users engaged and show them progress without adding additional wait time, and a loader is one way to do this. Loaders indicate to the user that progress is being made and additional data is being loaded. However, they also indicate to users that they are waiting for something. And if a loader lasts longer than it should and no additional UI changes are occurring, then this can be very annoying to users. And next here we have a transition animation. Transition animations are a great way to show progress and to keep users engaged while waiting for any necessary data to load for the next page. And it can be hard to match the total wait time to the length of a transition animation because notoriously they are pretty quick, just shifting from one screen to the next. And for example, we have here a popular online retailer. And in this video, a user swipes to purchase an item. And then we see a long pause here, followed by a transition animation and a blank screen. And after all of that, we finally see the order placed screen. And we didn't actually slow this video down at all. This is the one example where you're seeing the real speed. And in this case, the user does experience a lot of delays when trying to purchase an item, not only waiting for the transition animation, but there are also further delays after the transition has completed before the user receives confirmation. And here we have an example of layout updates and additional content loading. And for this last example, you'll see multiple layout updates occurring. And layout updates provide users with feedback showing visual progress that the content is loading. However, having a lot of layout updates in one flow can create a jumpy experience for a user. So in this example, a user launches the app, we see the splash screen with the logo, and then the blank layout and multiple layout shifts to communicate progress to the user before the content is loaded on the screen for the final view of the homepage. In this case, the splash screen and multiple layout updates communicate to the user that they have been waiting for something to load, and all of these updates can take away from a smooth user experience. So now that you have seen multiple examples of UI changes that can negatively impact the user's experience with the app, let's talk about why all of this is important. So why is performance-oriented UX design important? Well, let's just look at these stats. 52% of users suggest that they are less likely to interact with a brand if they had a poor experience with its mobile app. And this indicates that mobile apps performance plays a huge role in either helping to acquire or to lose customers. And additionally, we see here that 36% of users who have experienced slow performance issues had a lower opinion of the company. And this makes sense, right? Because if a user is trying to use a mobile app that is riddled with delays, that would leave a negative impression on them. And lastly, we see that 98% of users say that app performance, for example, an app's speed or responsiveness, matter when deciding to keep or delete an app from their mobile device. And of course, this makes sense. No one wants to use a slow app.
Thanks, Jordan. I'll take it from here. So we've just learned how we saw different examples of the slow mobile experience, and we learned how performance is important, not only to retain customers, to retain users in your app, but also for the whole brand reputation and for the whole experience with the brand. So, and all of us know how emotionally frustrating can be interacting with a slow app, how upset we get if we cannot book a flight because loading times forever. But now, if this is so important, and we all are trying to build great products, why isn't performance prioritized that much? Why haven't everybody fixed it yet? And here we get to the problem that performance is overwhelming. So to that point, there are a lot of different tools that are helping you with performance, with optimization of your apps. But first of all, without the pre-production tools, often delays would be discovered in the production when they are already launched to the users. It would be easier to spot delays with observability tools, but still knowing the delay exists won't always help you to find a core cause of the delay. Now, in addition to that, user experience is not always clearly tied to specific code events in your app. For example, the tap on the screen can be registered by the phone at a different time when your app will recognize the tap, and there can be a lot of stuff going on there, as well as the place where the last image, the last frame is ready to be rendered, and the place when it is actually rendered and appears on the screen, there can also be a time gap between then, and it's really hard to track specific metrics of what the user sees. And so far, if you're not an engineer, and if what I just said sounds too technical for you and you started losing attention, believe me, even for the engineers who wrote the code, uncovering that inefficiencies is not an easy job, and it's also overwhelming for them as well. And now last thing that I'll mention here is that a lot of different tools that would provide you with different metrics, again, would not always be tied to the user experience. And that is often reflects confusion of loading time with wait time, because the thing that we mostly see in different mobiles apps, and as an explanation of something to be loading slowly, is the slow backend, the slow work on the server. But then that loading time would not always be the same as the time that user actually has to wait. And what we're going to try here is to ensure that we're always minimizing the additional wait time that happens on the phone. Okay, so and here where the PS tool and the opportunity for improvement comes in place, because the PS tool would be the tool that will show you all the code that's executed in your phone, when and where it's running, and it will be synchronized with the screen recording of your phone. So you will see what happened on the screen and what happened in the code on the code level in the meanwhile. You'll see dependencies between the code, and then you'll be able to highlight the delays and see their core codes. So to that point, we'll get to see how PS tool works and how it indicates all of this. Before jumping into that, let's see a few examples, the most common causes of the delays, and then the examples of these delays happening with some additional explanation of reasons for that delays. Now, working with different apps across very different industries, starting from image editing and social networks and messengers, and going to finance and banking and retail, across different platforms, we've noticed that most of the delays that we see, the most impactful delays, and at the same time, the most easy to fix, actually come not from some complicated libraries, not from that much of the technical issues, but because of the interactions between front end and back end, and with like UX elements and the additional data loading and other code that runs in the background. And all of this causes basically split into two categories. One category is not starting to fetch data as soon as possible, waiting for some additional UI update, waiting for some UI element to appear on the screen before you start fetching the data, which can always be avoided. And the second is not showing data as soon as it is available. So there can be various reasons for doing that, waiting for additional data, waiting for some extra UI elements, anything like this, but not showing data when it is available creates additional friction, creates additional waiting time. Okay, let's go to see a few examples. And here there is a comparison example of two very similar apps. Both of them are dedicated to trading stocks on your phone. One of them, Robinhood, works on the US market. Flink is the top trading app on the Mexican market. And we're going to see here a very similar page loading process, which is when you click on a company that you want to trade stocks for. And then the company detail page loads, and you see some details about that company, and you also see the plot of how the stock price changes. And in this case, in this comparison video, you see how Flink, it takes Flink to show the company details page for almost 3 seconds, while Robinhood does it for as little as 1 second. Now, of course, it is a bit of comparing apples to oranges. You cannot always compare two different apps with different backends side by side and say that, assume that the backend conditions are the same. And that is, as I said, often delays that you see in the UI, delays that you see on your phone are blamed on the slow backend, on a large loading time, but that is not always the case, or even if it is, that can be just part of the issue. And here we're focusing on how to optimize everything without actually targeting backend, only by interplay between UI updates and the loading. And here, let's see why actually Flink had additional delay that Robinhood didn't. So let's dive first deeper into the example of Robinhood and see how the loading happens here. And here, what you see on the UI is that a user clicks on a company. Let's wait for here. User clicks on a company. Then there is a transition animation of the page sliding. And then almost instantly, the data about the page appears on the screen. Now, you still see a white screen for a bit, but the length that you see this white screen for would not be enough to fetch the data, to fetch all the stock prices that would be then shown on the now, what happens here in reality is that Robinhood starts to fetch the data to appear on the screen at the same time that user clicks on the company, because it is known which company they are going to open, so you're ready to fetch all the data. And then once this data arrives, without any further ado, it appears on the screen. So that's an example of efficient data loading process that looks pretty smooth to the user. Now let's see the Flink example that is very similar on the UX design stage. Because if you see all the elements that were designed here and how they are interplaying with each other, you see the same steps exactly. You'll see that the user clicks on the company, then there is a transition animation, and then after a while, the data, including that plot, appears on the screen. And there are two reasons for the data to appear a bit slower that are not tied to the backend updates. One of which is that, and this is what we very often see on very different apps, regardless of the industry or anything, that often data is being fetched only after some UI update happens, which in this case would be the end of the transition animation. And keep in mind that if you're only starting to fetch the data after the animation ended, you're by default creating a wait time there. Like, you will still have to wait and show something for the user while this data is being fetched. And the second thing is not showing data as soon as it arrives. And in this particular case, there are two views for Flink stock price plot representation. One would be like this that you see, the other would be candlestick view. And the candlestick view is not visible on the screen here. However, it's being fetched after this plot already loaded, but the data waits to appear on the screen until all the data is being fetched. So that creates extra wait time for the user. And once this is removed, the performance really speeds up. Okay, so now let's talk about, like, we saw the delays, we saw how unpleasant they can be in multiple examples that Jordan showed you. We'll also see what could be the cause of these delays. But now, if you're designing the app from scratch, how to make sure that these delays don't appear to you, because of course, each of us wants to create a fast and efficient product. Yeah. And here, what I would encourage you to do if you're designing the user experience is to start by thinking about the wait time that you need to cover. Because the purpose of all these intermediate steps would be to cover the wait time and to give the user the most smooth and the quickest experience at the same time. So once you have a list of the elements that you want to incorporate, make sure that each step is actually necessary, that you are not showing something just for the design purpose, but actually that there is a utilitarian use for that. And then the most important part is communication between the teams and communication about the purpose of each UI update, and making sure that it is clear what this UI update is covering for and how the wait time happens in parallel and nothing is delaying the next step. And for that, there is a diagram. So, and that is how, like, what we see is often when designing an app, there would be certain steps sketched of, like, first loading this data, first showing text, then showing images. And often that looks like a diagram on top with the user action causing some loading and the code running in the background. When the data is loading, there would be a UI update. Now, when that UI update happens, which can take a long time, which could be animation, which could be anything, and only then the next step of loading of some data will happen. And that red arrow on this diagram, this is something that should not, the dependency that should not ever happen. So one thing to make sure about, especially when when discussing between engineers and product and UX design teams, is to make sure that there is nothing holding back the loading process. And nothing holding back the code running in the background, like on the diagram below, where some code started executing right after the user tapped on the screen. And then when it finished loading, you can update your screen. That's okay to show progress, to show data in batches, but then that should not postpone the further code execution in the background, the further loading process. So code could be waiting out the blocks of code, but it should never be waiting for an intermediate UI update. And that's how you can check whether the design is used the way it's supposed to be. Now, one additional thing that we want to mention here is how to look performant without being performant. And that ties back again to the thing that I mentioned about backend, that not only, we're still tied to the loading time from the backend. This whole story about intermediate UI steps appeared from the fact that we still have to wait for some stuff to load from the server. But optimizing backend can be hard and can be very expensive. So one thing that you can do is to use your product metrics to predict what the next user's action would be. And to that experience, like here in the Instagram example that we saw before, when the profile page is opened and when we click on the picture, there is no additional wait time to load this photo. And that's not because the photo is loaded so quickly, but because the Instagram team realized that if someone enters the profile page, they're very likely to open full-size images in the feed and then scroll up and down. So what they do is that they start prefetching all those images to be ready to show them when you need them. And you can do that for the most common scenarios in your app or for the most essential ones, the ones that don't admit any delays. So that would address to the fact that you don't even always need to wait for the user's action to start prefetching this data, but that would always be on the product side. Like you would need to use your product metrics to predict that. So the engineers who are implementing the code would not know what the next action, would not always know what the next action would be. So that is, again, where the communication between product, UX design, and engineering is essential. Okay. And now the special case that we want to mention in the end, that we didn't include into all examples of the previous wait time, is the unblurring animation. And that is an example of UX element that we see very often. And the thing why we made it stand out of the whole elements is because it's not actually covering for any waiting time for data to load. The great part about unblurring animation is that when you're waiting for the data to load, like on this example of Airbnb app, is you don't just get your data to pop on the screen immediately. You make sure that it appears gradually, creating smooth experience, which is understandable. One thing to keep in mind is that unblurring animation would always create some additional wait time between the gray layout and then the data appearing on the screen, in full brightness. Now, that would look great on the high-end devices. That would look super smooth and super natural. But keep in mind that on low-end devices, this animation can be bumpy and can create much longer wait time than you're expecting. So when utilizing it, make sure that your animation is short, that it happens briefly, and then make sure that you know your users and you know which phones they're using, and you are adjusting the usage of this animation to the phone models that are most popular between your users. Like we see this with the example of some of our clients and such apps that are, say, investing in a rare collectible assets. They would know that their users use high-end devices, they're early adopters of technology, and they are generally wealthy. So there is more, like, it is more likely than their phone would be high-end. However, like other apps like messengers will have to support all different phones all around the world, the oldest possible phones with all different conditions, and they will need to test their apps on all of these phones and make sure that on none of these phones, they like such things as unblurring animation would create too much of wait time. Okay.
So far, we have outlined what UI interactions are and how to avoid delays when designing. But now we will highlight how to spot any performance delays using the product science tool. And as previously stated, the product science tool analyzes your code to pinpoint performance issues in multi-threaded environments. And our AI enables the tool to do it more efficiently by providing unique insights for data visualization to help identify problems right away. So now I will discuss the methodology for how we use the product science tool to identify any efficiencies in the execution of a mobile app's code. So step one. In order to use the product science tool, you must first record and upload a trace file and screen recording for the flow or part of your app that you want to analyze. Uploading the trace and recording to the product science tool will allow you to see exactly how your app's code is being executed. And this image here shows part of the UI of the product science tool. And the colored sections here are slices that represent functions that are being scheduled and called while any flows are being executed in your app. And the length of the slice shows the amount of time it takes for that function or process to execute. And as we discuss these steps, it may be a lot to take in, but Anastasia will also show an example of how all of these steps come together to allow you to identify various performance inefficiencies within a mobile app. And step two, after the trace file and screen recording have been uploaded to the product science or PS tool, this is what you will see. And as previously mentioned here, we see the slices in color, but we also see the video panel that shows the recording. And this feature is completely unique to the product science tool and allows users to use the video feature and our frame counter, which is also shown here, it is circled, to sync any delays that are shown on the UI with what code is being executed while that delay is occurring. So again, here we have our barcode and frame counter, which syncs the code on the trace file to what you're seeing on the video. We have a dedicated PSI frames thread that will match up with the numbers that you see on the video for a particular frame. And then we have our current time indicator that allows you to scrub through the video. So as you move the current time indicator, the video will change, the frame numbers will change accordingly, and then also they will match up with the frames for the PSI frames thread. So that makes it very seamless and allows you to sync the video with exactly the code that's being executed. And then now that we see we're on step three, so now that you have uploaded your trace file, you're using the video recording, you are able to use the video feature to find the last frame where the flow has finished executing. And once you find that last frame, you select it, as was done here. On this image, you'll see the last slice, you'll see the slice that corresponds with the last frame that's being executed or the final view. And when you select that slice, it will then highlight the execution path, which shows the connections between functions and the progression of the calls that were made while a user is carrying out an action in an app. And again, this is another feature that is unique to the product science tool. No other tool shows you these connections and shows you the progression of calls for a particular part of the flow. And from this point, the remaining step is to analyze the highlighted execution path, which Anastasia will demonstrate.
Okay, now quickly to wrap up our webinar, I just want to show you a few examples of how easy it is to use product science tool and how you can spot all of the delays that we talked about with its help. And here there is an example of one of the trace files where when the user of the tool clicks on the last frame or like the last UI change that you saw on the screen, the execution path that Jordan just mentioned highlights. And without getting into a deep dive into the code and understanding each smallest step, what's going on there, you can still understand. And if you zoom in the tool, you will see that there is a network request that is responsible for data to be loaded. Now you can always also follow these connections and see where this network request was called from, when it was scheduled, when it started. And if you go there, you will see that this starting point is not the same point as where the user tapped on the button. And you can see this both from the names of the slices here or from the video. And I'll show you to that in a bit. Now, what you will see, then you will want to understand, okay, so what is happening throughout this time, and what our tool will show you that this bit is the transition animation that was actually running before the app started fetching the data. Now, you can also scroll through all of the threads and see that no other code was executed at that time. So it wasn't covering for another network request or for anything else. It was just showing the animation while taking the user's time to wait and then adding additional wait time for the network request. So in this case, this animation wasn't used efficiently. But now I'm going to share my screen and show you a bit inside the tool. Jordan, can you stop? Yeah, thank you. Okay, let me share my whole screen. And here we are in the tool. So this is our UI. This is the famous video feature. And what I can do now first is just to play the video and explain you what is happening in the flow that we're going to analyze now. And if I play the video, we see the following thing. First, the user taps on an asset over here. Then there is a transition animation of like the page sliding to the side. And then there is this glancing animation that will last until the page content loads. So that's what I see on the screen. And I do see that there is, a delay that user has to wait for a while. Now let's see what's happening during this wait time. And if I click on the last frame, where the data starts to appear, the execution path will highlight. And I would see that it consists of a bunch of network requests that are interdependent. So they're waiting for each other, which is okay. But now I would go to the first network request. I would see where it was scheduled from, and I would see that it happened from the same place where user tapped on the screen. So I would go and check how is this loading process related to the animation? And over here, I can use the time indicator to scroll to the point where animation is over. That's around here. Oh, I even put a purple flag on it. Okay, so I see where the animation is running, and then I see that it actually covers the first network request completely. So this would be the modal use of the transition animation when it's used to support the performance and not to slow it down. So that's one of the examples of how easy you can either spot such an efficiency in product science tool, or you can check that the fix was made right, or you can just confirm that everything is running as planned. And here is another example of before and after fix, just to show you how different results can look on the video. And that is an example of a Popshop Live app, where before fix, it used to take over 6 seconds to load the home screen. And after fix, it became as short as 2300 milliseconds. And here we see that the data loads much faster after the splash screen is completed, as well as this improvement was achieved by rescheduling network requests to interact more efficiently with the splash screen. So that's an example. And now, wrapping up the webinar, a quick recap of what we just discussed today. And that is that there is a problem that a lot of apps have delays, have performance inefficiencies. And most of them come from late data loading or not showing the data when it is already available to be shown. The real user experience often differs from the multiple metrics from the data that you can collect by observability tools and other available tools, and that even for the engineers who wrote that code, finding the cause of the clearly noticeable delay can be overwhelming. So even though everybody wants to create a performant and efficient product, it's not always easy to get to that point. And here is where PS Tool comes in, because PS Tool allows you to visualize your code and understand how it affects user experience due to our unique trace video synchronization feature. That feature, together with showing the execution path, the dependencies on the between the code events, clearly highlights the delays and provides you with the root cause of the delays. That's how you can get actionable insights on how to improve your app, how to speed up your app without spending too much time and effort on it, make it faster, and keep creating amazing products. So at this point, I'll finish. I encourage you to sign up for our free trial. Also, feel free to attend our future webinars, and we'll be happy if you join our community. You can use this email, sales@productscience.ai, to connect with us. And if there are any questions at this point, I would be happy to answer them.